My field of research is around sensors and informatics for use in agri-food. My research is based at Manchester University because I think it's the diversity of skills here. We act as a hub in the School of Electrical Engineering and Electronics, basically bringing together a lot of different technologies, such as the physics, the chemistry, the materials engineering for sensor systems, the biology, the plant science. We bring it all together, but we have to partner with the others as well. Agriculture and food is becoming a massive issue now. We no longer have the wine lakes and the grain mountains of the 1970s. It's almost like a perfect storm. We've got climate change, we've got competition for land in terms of urban growth and populations. We've got high protein diets. You know, as in one end we've got people becoming more wealthy, wanting to eat more meat. And if you do that, then you consume more grain, you consume more land in actually doing that. Bring that all together and we have basically a perfect storm, which is meaning that we have to produce more food with less. My research helps lead this challenge because what we're trying to do is make, I suppose, farming be a bit more smart. We bring in sensors and new ways of getting information to farmers and to the agricultural supply chain, all the way through to the consumer, so that we can actually produce more food with less inputs. What I'm most concerned about is probably the gap in understanding that some cases the funding bodies, some cases industry in general have in what engineering can be. Engineering is not big tractors and big combine harvesters. Engineering can be the subtle, smart elements. Your mobile phone, your computer system. It's that part of engineering built into sensor systems can make a very different way of doing things. And if engineering is being treated as basically mechanical systems, then we fall between the cracks between what funding might be available for biological research and what's available for the engineering research. Looking ahead, I think what excites me most is what we can see below the soil. The soil is invisible, but with sensor systems we can actually start looking at the interaction between plants and the soil, all the flora and fauna below the soil. There's a whole microcosm occurring underneath the soil, which there has not been real-time information available on. So combining that with what we see above the soil, almost like I suppose, an iceberg, looking at the top of the iceberg is what we see with the crop. What happens below the soil is the 90% that you don't see, and that's where the real new challenges occur.